right, here we go. Factoring trinomials with a coefficient greater than 1, part 2. Don't you love my little graphics? I don't have any of that fancy stuff that you guys have. All right, so let's look at this. You're going to use this kind of strategy when your numbers are huge. So look at this. We have 45, we have 95, and we have 50. So what we need to do is you can see if we can pull a GCF out. Well, one thing is they all end in 5 or 0, so we know 5 can go into it. Now, do you remember the upside down cake method I had showed you guys? Where you take the 45, the 95, and don't worry about the negative sign in front of this. Let's just try to find this. Let's see, 5 goes into 45 9 times. Let's see, get my calculator out. 95 divided by 5 is 19 times, and then 5 goes into 50, 10. All right, now do I have a common factor of 9, 19, and 10? No. So that's going to be my GCF, which is going to be the 5. So what I'm going to do is I'm going to pull the 5 out. I'm going to factor using distributive property backwards. So 5 times what is 45x squared? That's going to be 9x squared. 5 times what is negative 95x? Okay, that's going to be negative 19x. Again, that's all the answers are right here. And then 5 times what is going to be 50, and that's a positive 10. Okay. All right, so now we have to work from there. We don't do the can't do the shortcut on this one, but if we need to do what we did last time, we need to take the 9 and multiply it by the 10, and we get 9 times 10, which is 90. All right, what are two factors of 90 that add up to equal negative 19? This is pretty easy, 9 and 10, but the problem is I need equal negative 19, so they have to both be negative. So negative times a negative is a positive, and a negative plus a negative is a negative. So what I'm going to do is I'm going to rewrite this. I'm going to pair the 9 with the 9 and the 10 with the 10. So this is going to go back down to the quadnomial, which is the 4. So I'm going to have negative 9x, don't forget to put the variable, and negative 10x. Okay, and then I'm going to bring down the plus 10, and then I'm going to bring down the 9x squared. Then from there, I'm going to factor by grouping. So here I'm going to pull out the 9x, which is going to give me x minus 1, which I can cheat. I know that this is going to be x minus 1 as well. So x times what is negative 10x? And negative 10. So now inside and outside, I have x minus 1. I have a 9x minus 10. And then I have this guy that I pulled out in the beginning that goes here. And I'm finished. So I have 5 times the 9x minus 10 and the x minus 1. Okay. Always, as well, get in the habit. If you could look down here at one of your two binomials and you can pull out another GCF, pull it out. Because what that would mean is you didn't pull the GCF, the biggest number or the greatest common factor out in the beginning. And you could just do it again. All right, so let's look at another one. All right, 24, 231, and 90. All right, so let's look at this. 24, 231, and 90. All right, well, looks like we're going to have, do you guys know how to remember how to tell if something's divisible by 3? 2 and 4 is 6, that's divisible by 3. 9 and 0 is 9, that's divisible by 3. 2 plus 3 is 5 plus 1 is 6, divisible by 3. So 3 can go into all of these. So let's see how many times. 3 goes into 24 8 times. Let's see, 231 divided by 3 is going to be 77 times. And 3 goes into 90 30 times. Okay, now, do I have a GCF or a common factor of 8, 77, and 30? No, I don't, because 77 is only going to be 11 and 7 and 1 and 77. And this will be 6 and 5. 2 would be common here, but not here. So yeah, we're done. So GCF is going to be your 3. So let's pull a 3 out using the GCF method. So 3 times what is 24n squared? That's going to be 8n squared. Plus 3 times what is 231n? Well, right here. Got it right there. Right here. That southern accent come out. And then 3 times what is negative 90? That is going to be a negative 30. Okay. All right. Still kind of a big number to deal with. So what I need to do now is I need to multiply 8 and negative 30. And that's going to be negative 240. Okay. Now I got to come up with factors of negative 240 that equals 77. So we know one's got to be positive, one's got to be negative. The bigger one's going to have to be positive. So 24 and 10 are definitely not going to work. Let's see. Let's just try 8. Oops, wait a minute. So 240 divided by 8 is going to be 30 and 8. That's not going to work. Let's say 240. Let's just try 24. I'm just trying all sorts of things. I already did that one. Let's see. See, this is where it can be tedious. Divided by, let's just see if 15 goes in there. 15 and 16, but that's not 77. All right, what about 50 is not going to go in there. What about 240 divided by 60? 60 and 4, we're getting bigger, but that's still not going to work. 240 let me see, maybe 80. 240 divided by 80. 80 and 3. You guys probably would have gotten that faster than I did. All right, so 80 and 3 are going to work. But the problem is I need positive 77 and negative 240. So which one of these needs to be negative? The 3. So it's going to be negative 3. Okay? All right, so what I'm going to do, again, this can be the most tedious part of these problems. Once you get this, it's kind of easy. So I'm going to replace my one term with two terms. Now, again, look at how you pair it. I'm going to put the 80 with the 8, and I'm going to put the negative 3 with the 30. So I'm going to put 80n minus 3n. Again, that's a positive 80n. I'm going to bring down the negative 30. I'm going to bring down the 8n squared. And then I'm going to factor by grouping. First two, last two. This one I can pull out an 8n, which gives me n plus 10. So I know for a fact that this has to be n plus 10. So n times what is negative 3n? Negative 3. So I have 8n minus 3 times n plus 10. Just double check here. Can I pull a GCF out of either one of them? Nope. But look at this little guy that we pulled out in the very beginning. He needs to come down here. And so we have negative 3 times the sum of 8n minus 3 times n plus 10. All right, so let me give you one that I want you to try, and then we will go over it. Okay, so try this one. 20x squared minus 46x minus 84. So why don't you pause the video and try that one. And we're back. Okay. I'm going to come over here and I'm going to do 20, 46, and 84. I know 4 goes into everything. 4 goes 25 times. 4 goes, maybe not. 46 divided by 4. Nope, it's not 4. So let's try 2. So that's going to be 10. 46 divided by 2 is going to be 23. And 2 into 84. 2 goes into 8 4 times. 2 goes to 2 twice. 15, 20. This thing messes everything up because that's prime. So my GCF is only going to be 2. So you pull out I'm sorry, you can see that to be a 10. So I pull out a 2, and I'm going to have 2 times what equals 20x squared, 10x squared. 2 times what is negative 46, that's going to be negative 23x. And 2 times what is negative 84, and that's going to be negative 42. Oh, there's another one that's going to be tedious. All right, so we now need to multiply 10 times negative 42. 10 times negative 42 is negative 420. All right, we're trying to get negative 23. Well, negative 42 and positive 10 is not going to work. They'll give you negative 32. Let's see, 420 divided by 20. 20 and 21, that's not going to work. We get the 10. Let's see, 420 divided by 5. Nope. 84 and 5 is not going to give us 23. Let's try 15. 28 and 15 is not going to give us that. 420 divided by, no, it's not going to work. Let's see, 420 divided by 6. 70 and 6 is not going to work. See, this can be the most tedious thing ever. So let's see, 420 divided by, get that 10, 20, 50, let's try, we already did 70, 60, let's see, 420. That's fun, you get to listen to your teacher working on a calculator because I didn't figure this out before I gave it to you. 60 and 7 still doesn't work, dang it. Is that right? 420 divided by 60, 60 and 7. Let's see, 420 divided by 7. We already got that. Duh, my 7s. 420 divided by, not 42 and 10, 23, dang it. Divided by 16. Nope. 420 divided by, well, dang it, guys. I could sit here all day. 420, 10. This is my bad. I should have gotten 420, 42, 20, 21, 84, 5, 28, 15, 6, 420. You're probably screaming, it's this, Miss Evans, it's this. And I can't hear you. 18, 420 divided by 30, 30 and 14. Nope, still doesn't work. 28, 15, 70, 60, 30, and 14. Well, darn it. Let's see, 420 divided by, I'm about to tell you just to pause this, and I'll post the answer once I figure it out. Or you're going to sit here and watch, just forward it until I get to the final answer. So 420, good Lord, 20, 4, 5, 120, nope, 5 by 16, nope. 30, 40. This is why I need Mr. Evans here, and he's at work. He's listening to me mumble. 420. And I think I already shut it down on my computer, so I can't go sneaking out. 80. Well, son of a gun. You know me better. I would have said something different. 420 divided by, no, 420 by, oh. All right, I'm going to cheat. Hold on, let me go see if I find the answer. Ha ha ha! I'm back. All right, I cheated. It's negative 35 and 12. Again, this is going to be the most tedious part. All right, so I am going to pair the 12 with the 42 and the negative 35 with the 10. So I'm going to have negative 35x plus 12x. I'm going to bring down the minus 42. I'm going to bring down the 10x squared. Okay, and then I'm going to group the first two and the last two. I'm going to pull out a 5x here, which is going to give me 2x minus 7. So I know this side has to be 2x minus 7. So 2x times what is 6x? 12x, duh, 6. And 6 times x is 42. Good. So I have 2x minus 7 in one. I have 5x plus 6 in the other. And the 2 you put down. So you guys might have taken as long as I did to do that, but again, I was able to cheat because I had the problem on the computer. Okay, so again, this right here can be the most tedious part. That's why I'm not going to give you that many to do. All right, I'll talk to you later.